Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. VHF omnidirectional range. We are going to discuss about the introduction, its basic principle, conventional VOR, Doppler VOR and ramp testing. Introduction. Very high frequency omnidirectional range VOR is a type of short range radio navigation system for an aircraft, enabling aircraft with a receiving unit to determine its position and stay on course by receiving radio signal transmitted by a network of a fixed ground radio beacon. It uses frequency in the very high frequency band from 108 to 117.95 MHz. Developed in the United States beginning of 1937 and deployed by 1946, VOR was the standard air navigational system in the world. Basic principle. The frequency range of a VOR is between 108 MHz and 117.95 MHz. Every VOR is oriented to the magnetic north more than this in a bit and emits 360 radials from the station. The VOR sends out one stationary master signal and one rotating variable signal. These are also called as reference and variable phases. An aircraft's VOR antenna, which is usually located on the tail, picks up the signal and transfers it to the receiver in the cockpit. The aircraft's VOR receiver compares the difference between the VOR variable and reference phase and determines the aircraft's bearing from the station. This bearing is radial that the aircraft is currently on. Have a look at the picture of VOR antenna. It is located on the tail of the aircraft. What exactly is a VOR station? A VHF omnidirectional range radio VOR is the most common ground-based navigational aid NAVAID you will use. VOR navigation also allows your aircraft to fly point-to-point established along with the airways between VORs. While some VORs are being slowly phased out by the FAA, there are still hundreds of VOR stations around the country. They're valuable source of position information for the cross-country flight, instrument approaches procedure, and if you get lost, they can help you quickly pinpoint your position. What are the DVOR and how do they work? A DVOR, Doppler VHF omnidirectional range, is a short medium range radio navigation system used to aid the aircraft in determining their flight position and direction in relation to their destination using VHF very high frequency signal between 108 to 117.95 MHz sent from a radio beacon. DVOR are an International Civil Aviation Organization ICAO standard navigational aid that assist aircraft in their approach by sending omnidirectional signal from the ground radio beacon located at airport and runway. These signals are sent from transmitter located in a network of VOR station. These stations hold arrays transmitter that spin horizontally, sending out very high frequency VHF signals ranging from 108 to 117.95 MHz. Due to their high frequency, they rely on the line of sight from the transmitter to receiver. When the receiving unit collects these radio signals up to 200 miles from the receiver, the transmitter, they can pinpoint their position and enable the aircraft to remain on course. CVOR and DVOR, here are the system interface. With our team of experienced engineers, we supplied and installed DVOR to airports across the globe. These Doppler VORs are an advancement of the previous conventional VOR, CVOR, and enhanced signal accuracy and quality due to their ability to differ and the effects reflection from surrounding hill, mountain, and building. Have a look at the image of CVOR and DVORs. Characteristic. VOR signal provide considerably greater accuracy and reliability than NDBs due to a combination of factors. Most significant is that VOR provides a bearing from the station to the aircraft which does not vary with the wind or orientation of aircraft. VHF radio signal is less vulnerable to diffraction, coarse bending around the terrain features and coastline. Phase encoding suffers less interference from thunderstorm. VOR signal offer a predictable accuracy of 90 meter 300 feet, 2 sigma at 2 nm from a pair of VOR beacon as compared to the accuracy of unaugmented global positioning system GPS, which is less than 13 meter. 95% VOR station being VHF operate on the line of sight. This means that if on a perfect clear day you cannot see the transmitter from the receiver antenna or vice versa, the signal will be either imperceptible or unusual. unusable. This limits the VOR and DME range to horizon or closer if mountains intervene. Although the modern solid-state transmitting equipment require much less maintenance than the older unit, an extensive network of stations needed to provide reasonable coverage along with the main air route is a significant cost in operating current airway system. Ramp testing. Testing of VOR should be always carried out with a ramp test set capable of being tuned to any VOR frequency, radiating sufficient energy to allow satisfactory operation of the VOR and providing a means of simulating various VOR radials. Most test sets are including provision for testing ILS as well as VOR. Actual testing should be carried out in accordance with the procedure laid down, but briefly it would involve correctly positioning the test set antenna and radiating on sufficient frequency to test frequency selection of VOR. Sensitivity may be checked by reducing the RF level received either by the use of test 68 set attenuator or moving the test set antenna further away. Various bearings should be simulated. Check whether they are to or from the station, and appropriate reading should be checked on the RMI and the OBS operated so as to check the manual mode of VOR. This was all about the VHF omnidirectional range. Thank you.